2.3 continues where we left off in 2.2, and this time we're going to be simplifying the variable expressions. Now, both in 2.1 and 2.2, we were coming up with variable expressions, and now we need to learn how to simplify them. A couple of the terms that you need to know are there are terms in each equation, and those are marked by the black arrows there, and some terms that we will be using quite frequently in pre-algebra are coefficients. Coefficients are here in green, the 5 and the 4, and those are numbers that are used to multiply by a variable. They come before the variable, so 5x, the 5 is the coefficient, and 4x, the 4 is the coefficient. Now, when we're looking, and then let's just do number 7 there. I didn't talk about that one. Number 7 is actually referred to as a constant term. 7 will always be 7. The x's might change in value depending on what we substitute in, but 7 is always a constant term. So like terms are terms that have identical variable parts. So if we identify the parts of an expression, we have an expression here, y plus 8 minus 5y minus 3. So we can rewrite it as a sum, and now it says identify the parts of this expression. And remember, whenever we're talking about y and it does not have a coefficient, it's an implied 1. So if we just talk about the terms in this one will be y, 8, negative 5y, and a negative 3. Now, the coefficients are going to be 1 and negative 5. And I got the 1 from the implied 1 that I wrote in with the y. Okay, so don't forget to always have 1 if there is a variable without a coefficient. The constant terms in this expression are 8 and negative 3. Those are the constant terms. And then the like terms would be y and negative 5y and 8 and negative 3. These are the terms with coefficients and variables. These are the terms of the constant terms. Now that we've identified all of them, we will be able to simplify by putting those terms together. So in example 4n minus 7 minus n plus 9. First I'll show you by rewriting using the commutative property. I can change the order of my expression. So I'm going to put my terms that have variables first. So I've used 4n. I'm also going to put in there a negative n. Notice I took the operational sign as an integer sign now. I'm going to then go to my constant terms, negative 7 and positive 9. Now to simplify, I can combine those terms. I had 4 n's and I subtracted 1 n, so I end up with 3 n's. Remember, there's an implied 1 there. I have negative 7. I'm going to add or combine that to a positive 9. So in that case, I end up with a positive 2. Different signs, find the difference, give the sign of the larger. So this is my new simplified expression. So let's see how I'm going to do the next one. You're going to see we also have parentheses in this one. So before we can do any simplifying, we need to do that. So I'm going to distribute that. So 2 times x is 2x. 2 times a negative 4 is a negative 8. We have 9x. It's a positive. And we have a positive 1. Now, I'm going to show you a little trick that I use. I sometimes just go ahead and I label these. So I'm going to look at all my terms that have variables. And I have a 2x and a 9x. So I can go ahead and rewrite them, group them that way, or I can just add them mentally. 2x plus 9x gives me 11x. So I'm going to be combining them now. I have a negative 8 and a positive 1. If I combine negative 8 and a positive 1, I end up with a negative 7. So I have 11x minus 7 as my final simplified expression. All right, moving along. Another one with a distributive. So the 3k, there's no operation being done with that yet. However, I have to distribute the negative 8. So I'm going to do a negative 8k and negative 8 times a positive 2 would give me a negative 16. Now I can combine like terms. I don't have to change order here. They're right in that order. So 3k minus 8k would give me, plus a negative 8k, would give me 5k, negative 5k, sorry, I didn't say that correctly. And then my only constant term is negative 16. So this is now the simplified expression. Moving on, this time notice that I have parentheses with a quantity in it, but I don't have a coefficient. When that happens, I do have an operational symbol. I have a negative or a subtraction. So I'm going to go ahead and I'm going to put my implied 1 there. I'm going to rewrite that. It's just kind of close there. So I had 4a minus. I'm going to put my implied 1 in there. And I'm going to rewrite this. Now, let me get rid of the other one that I implied there. And the other way we can think about it is, we've talked about this before, this also means opposite. So you're going to see what happens when I distribute that negative 1 there. So the 4a will stay the same at the beginning. Now negative 1 times 4a would give me a negative 4a. And negative 1 times negative 3 will give me a positive 3. Now, if I was going to use well, let me switch my colors there. Let me try it on the screen. If I was going to use my opposite rule, it would say make everything in that parentheses opposite. So my 4a would turn into negative 4a, and my negative 3 would change into positive 3. That negative outside the parentheses can either be thought of as a negative 1, or it can be thought of as an opposite of everything that's in the parentheses. Now I can go ahead and I can combine like terms. My tools are just not working for me on my iPad. So negative 4a minus 4a, or 4a plus a negative 4a, is going to cancel those out. And so my answer for this one happens to just be 3. Another thing to point out is you'll see how I'm solving going down as I simplify. That is the method we use in algebra. So you're wanting to put the simplified ones right underneath each other in that process. All right, and that actually finishes us off for lesson 2.3 of simplifying variable expressions.